Welcome once again. Good evening, everyone. Welcome to the 117th video in the Misconceptions in Physics video series. We were discussing from the last lecture on logical reasoning problems. And so currently we are looking at mechanics problems. My name is Ratankar Rao. I teach physics in an international school in Bangalore. And my passion is to do these videos. And apart from it, I also take private tuitions, coaching classes, and so on. Anyway, thank you for visiting my YouTube lecture. If you have accidentally stumped on, do glue to it. Okay. Now, let us start with the problem without wasting your time. So, now the question here, just a minute, let me just pull my video on the other side. Right. Okay. The question here is about you have a block of base 10 centimeter into 10 centimeter. It's a three-dimensional question here, and height 15 centimeter, kept on an inclined plane. So this is my inclined plane, and then making an angle theta here. And I have kept a block whose height is 10 centimeter, 15 centimeter. And the thickness and the width here, okay, are seen to be 10 centimeter into 10 centimeter. So this is how the block looks like. This is how the blocks look like. Okay. Now the coefficient of friction, the angle of inclination is theta, the coefficient of friction is √3. So mu is equal to √3. It's given here. Then the angle of inclination is theta and the horizontal plane is gradually raised from 0 degrees. So initially this plane was horizontal like this. And then what I did was, okay, I just started lifting it upwards like this. Okay. So this was the plane. Let me take an example. For example, this was the plane. Initially this was the plane. Then I started lifting it upwards like this. Right? So this is what had happened. Maybe if you're not able to see, you can see this one. Okay, I lifted it upwards like this over here. So therefore, what is the angle here? This is my angle. Okay, so this angle is the angle theta here. This is the angle theta. Okay. Now, then theta equal to 30 degrees. Okay, this is a question which has been asked in JEE Advanced paper in 2009 in paper 1. And theta equal to 30 degrees, the block will start sliding down the plane. Okay, theta equal to 30 degrees, the block starts sliding, first option. Then theta equal to, and the block will remain at rest on the plane up to certain angle theta, and then it will topple. Okay, so he says, okay, it will remain until certain angle, we do not know what angle, then it will topple. That means what? It will start rotating, it will fall down like this over here. Okay, it will just bend like this. A theta equal to 60, block will start sliding down the plane and continue to do so at higher angles. A theta equal to 60, okay, so if you still lift it upwards, a theta equal to 60 would be somewhere over here. Theta equal to 60 would be somewhere over here. If you had lifted it until here, then it will start sliding. Until that, it will be just standing there. At theta equal to 60, the block will start sliding down the plane. And on further increasing theta, it will topple at certain angle theta. That means at theta equal to 60, it only slides. If you make 61, then definitely it will topple. It will topple. 4 options. Now, we understood the options. The student response is that he tells that at theta equal to 30 degrees, the block will start sliding. Okay, why? How would you assume something like this? Some of them said, okay, sir, I assume the first option to be right. Okay, every time first option need not be right. Yeah. So then this is the coefficient of friction is equal to tan 30, which is equal to √3. Now, what is so special about tan 30? Let us understand the mechanism of sliding. When does an object slide? So what happens is when you have an object here, okay, so the force that is acting downwards is nothing but mg sine theta. Where does it act? It's act at the center of the block. Mg sine theta acts over here. Okay, and there's a frictional force here. What is the frictional force? Frictional force is nothing but mu times n, where n is nothing but mu times mg cos theta. This is what it is. Now, what does he say? He says that, okay, we need to find out the, now we have, what all we have? We have mg sine theta equal to so much, and f is equal to so much over here. Now, we know that mu is equal to tan theta. What we have learned about this, we have called this as the angle of repose. Angle of repose, mu equal to tan theta, which means if you have been lifting this plane slowly upwards like this, at a particular angle, the object starts sliding. Okay, so I have taken this example. Now, if I substitute the value of theta equal to 30, tan 30 would now be equal to, what's the value of tan 30? √3, which means what? So the sliding friction is seen to be √3. If you increase it more than this angle tan theta, then what will happen? The object will slide. So therefore, he thought, since the coefficient of friction is equal to this angle of repose, so definitely the object should slide. any angle beyond this, or maybe at theta equal to 30 degrees, it should slide. Now, what you have forgotten to analyze here is that logically you should understand that I am not giving you a point object. Okay, this is always true only if it's a point object. Okay, which means what? The center of mass of this system is very closer to this object. But you see, the length, the height of this object is 15 centimeter. 15 centimeter means what? See, the center of this mass, center of mass of this object is at 7.5 centimeters from the ground, from the base, from this inclined plane. So as a result of it, now this mg will act here. Mg will act here, and this is the point of contact. So what will happen? There will be a torque introduced, right? You see, there's a finite perpendicular distance. If you want, I can just zoom in. So this is my block. This is my block. This is my inclined plane. This is my inclined plane. Okay, this is my inclined plane. So this block is looking like this over here. The block is looking like this. This is how the block looks. Okay. Now, the center of mass is at this point. So as a result of this, the center of mass is at a distance from the contact over here. And there's a small r over here. So this force mg multiplied by this r will definitely introduce a toppling effect. And hence, the mass will now fall down. Okay. And it will topple. What do you mean by toppling? Rotating. Okay. That can happen. So this will definitely happen. Okay. But if this center, if I do not want this to rotate, what should be the cause? The cause is because of the height. Okay. So the height should be reduced. Chota wala. So what I want is, I want to reduce this one to something like this. I want to reduce it to something like this over here. I want to reduce it to something like this over here. When I do this, now what will happen? The center of mass is very closer here. Okay. And the distance r is reduced. Mass could be anything. Okay. Then the r is very, very small. If the r is very small, the toppling effect is very, very small. How do you know toppling effect is small? Because what decides toppling is nothing but a factor known as a rotating force, which is a torque, which is given by your force multiplied by the distance. Which force? The force acting on the object. And which r is the distance of the force with respect to the fixed point. Now, which is a fixed point? The base here is a fixed point. Okay. So therefore, with respect to the fixed point, there is a finite distance, and hence you are able to rotate the object. Now, if you reduce this value, the torque will not be there. If I make r equal to 0, definitely torque becomes 0. The object will only slide. Okay. So somewhere the dimensions plays an important role. This problem is not a normal problem. You should first understand that. Okay. This problem gives you something special over here. When we give problems like this, okay, we will never give the dimensions. We will only say a particle of mass m equal to 5 kg is kept on an inclined plane. Now, when I ask this question, particle of mass 5 kg, what do we assume? We assume that the center of mass is nearby to the plane over here. Now, when I give the dimension, I am telling you very clearly, center of mass is farther away from the plane. So as a result of it, it does not slide, okay, 30 degrees. So what can happen is, even before 30 degrees itself, it will start toppling. Maybe at 10 degrees, it will start toppling. So therefore, A is incorrect and B is the correct answer. Okay. So this is how logical reasoning plays a very important role. But if you do it, if you reason it incorrectly, you will not be able to get the solution correctly. Thus, thank you friends for watching these videos. These videos have not been uploaded in my website because of some technical errors. Shortly, this will be uploaded. So until that, you can subscribe to my channel and you can view these lectures. So every day at 7 p.m. it will be broadcasted, so you can look into it. Thank you for watching. Do like, share, and subscribe to my channel. This means a lot for us, okay, as a token of appreciation. And definitely it will help me out and also in monetizing. That was the goal, or it's a game actually. So thank you, friends.